When trying to match up the correct function here, there are a couple ways to approach it. One is I would say x-intercepts are the easiest way to start eliminating answer options. So for example, the only two x-intercepts here, -1 and +5. So if those are x-intercepts, the factors, by simply moving the number to the other side, are x plus 1 and x minus 5. So x plus 1, x minus 5. Those should be the only factors. So based on that, I could eliminate c because it throws in this additional factor. And I can eliminate d because it has x minus 1 instead of plus 1, and it has x plus 5 instead of x minus 5. So now we could look at options A and B. A couple ways to approach it at this point. Notice this exponent is 1, so are these. So that makes this a cubic function when you add the exponents, versus this is quadratic. And if you know anything about quadratics, you know that a quadratic function should either look like this or like this. The graph that we have in front of us is neither of those. So really, we could eliminate B and know that the correct answer option is A. That being said, I do believe that a good thing to know for graphing polynomials is the difference between when the function would bounce at an x-intercept versus when it would go through. And in this document that I created for my students back when I was tutoring someone in pre-calc, we definitely want to determine and plot x-intercepts, and we took a look at that. We won't talk about end behavior in this video, but multiplicity, the idea is if the x-intercept has an even multiplicity, which I'll show you what that means, you bounce. Very similar to if you have x squared, which is even. Notice it makes like a U shape, it bounces, versus if it's odd, like to the first, third power, etc., it goes through the x-intercept. And notice, since this particular x-intercept bounces on the x-axis, it should have an even multiplicity. So the x plus 1 factor should have an even multiplicity, which in option B, it has an odd one, which doesn't match. And then at 5, it goes through, so that should have an odd multiplicity, both of which have that, but we already eliminated B. So the answer is A.